Hello everyone. In this recording, we are trying to convert this pseudocode for which is a random algorithm search for bin packing problem to a Python code, and then see how it works, and also do some correctness test on the Python code. So first of all, here is the pseudocode that we have for random search bin packing problem, and what we try to do in this series of recordings is to cover these two lines of code, which is generating a random permutation of the items and then pack items in that order using a chosen packing rule among those fours that you saw on Thursday. So the point here is that comparing this random algorithm for bin packing to what we had for the knapsack problem is that if you go back to your knapsack problem, we have these two lines of code that we generate a possible solution or a random candidate solution S, and then we check the feasibility of that possible solution, randomly generated possible solution. But here we don't have that separation. So these two lines together, the output of these two lines is going to be a feasible solution. So we don't have the sequence of having a possible solution and then checking the feasibility. We have these two lines that the outcome of their combination will be a feasible solution. So to do that, first we need to generate a random permutation of the items, and so we can go here. We have this pseudocode for generating a permutation. So simply we can just copy paste this pseudocode and ask chat to convert it to a Python code. Forwarding this one, and here we have this one. Okay, so yeah, here we have the code. Okay, so it's a little bit, yeah, that's fine. So the thing is that I wanted to mention here is this name here, Fisher Yates, which is a very famous, let's say, pseudocode to do the shuffling or creating a permutation. So we just simply copy paste this one to the Colab and see how it works. So first of all, we imported a random library because we wanted to generate a random sequence or a permutation of numbers. And then we have the list of items. We have 6 items here. And then what we do here is to, okay, let me do something here before copy and paste this one. To make it a little bit simpler, I'm going to ask it use for loop. It's easier and a little bit safer to use the for loop. So let me copy this one and paste it here. So again, we imported the random library. We have the list of items. We have 6 items here, and then we have the length of that, which is equal to 6. So what we do here in this one, as you can also see in the pseudocode, we start from n going backward to the beginning. So this is exactly what we do here in the code. So we start from I starts from n, and we go back to 1 and 1 is excluded, and this is the step which is -1, and then we choose a random integer from 1 to I, from 1 until I, and I is also included, and we keep that in J. So J is actually the index of the item that we want to swap with what we have in I. In the next step, we define this temp, which is a temporary variable, and we store whatever we have in I. So one thing that here is, and we saw this several times, because the pseudocode that we had starts from I index, their indexes all the time, it starts from 1. So we have this problem. So we actually, one thing that we can do here, to make it a little bit easier Python wise, we can get rid of this one. What we need to do here is, so I is on, this one is going to be 0, and also we don't need to have this, -1 all the time. So what we need to do, so there is no difference between what we have here and we saw previously. I just wanted to simply start indexing from 0, which is conventional in Python and in many languages. So here we have, this is the same thing. So we just have a random integer. We start from n-1. So because n is, we have 6, so n is 6, so we started from, sorry, the length is 6, and we start from the last item, which is its index is 5, because indexing is start from 0. So this is 0, this is 5, so we start from 5 and we go back to 0 excluded by a step equal to -1. So we generate a random integer from 0 to I, which is n-1, and then we have this temporary variable that we store whatever is in I in the temp, then whatever we have in J, we put it in I, and whatever we stored previously in temp, we put it in J. So we actually have reswapping using this temporary variable that we actually call it temp. So if we run this line of code, we see that we have a permutation, a random permutation of that list of number from 1 to 6. So you can see that here. There are two things that we can do to improve this line of code. One of them, which is more efficient than what we have here, is to get rid of that temp variable. So one thing that we can do here is to have this one. So we wanted to store whatever is in J in I and vice versa. So I'm going to say I J comma I and then I'm going to have I and a J. So this line of code is exactly equal to this one. So here we define a new variable, this temporary variable, but here if we use this one, this is more efficient and actually does the same thing as here we had. Let me show you how it works. Let me fix the seed here again, random.seed, and make it equal to 13, and I'm going to make it comment here. So if I run it, so this is going to be the sequence 415263. Okay, so if I'm going to activate this line of code and therefore instead making this a block of comments, so now we are just using this one. So if you run it, so this is 415263. If I run it again we have 415263. So this line of code is exactly does the same as this one. So here you don't need to define a new variable. So since this version is better, I'm just going to simply get rid of this one and continue with this form. The other thing that we can do here is that we can use a function in random library which name is actually shuffle. So let me import the random again, and I'm just going to copy this one to see you how it works here. So we have a function in random library which name is shuffle. So I'm going to call not A, I'm going to call it B this time. B is the list, so this is list of range of, we have 1 to 6 here, so I'm going to have 1 to 7. So this line of code generates a list from 1 to 7. Okay, so if I print B here, this is going to be a list of numbers that starts from 1 and ends at 7. So sorry, 6, because 7 is excluded. So we have this list 1, 2, 3, 4, 5, 6. So when I have this B, I can use that function that I told you, random.shuffle, and what we want to shuffle B. Okay, so the B is here, and then I'm going to print the new B, which is the shuffle version. So if I go back here and so the list is 1 to, so okay, so if I run this line of code, I can see this is 415263. So this is a shuffle version of B, and as you can see, because I fixed the random, this is exactly what we had previously using this line of code, because what is behind this shuffle function is exactly this logic. So instead of having that block of code which is larger than this one, you can simply use random.shuffle and the output is going to be the same. Let me, before concluding this recording, show you something that in case that we want to have a list of permutations. So we can have for I in range of, let's say, 10, and we are going to do that for them. So we can do this. So we are going to have this one, and we print which we are going to have 10 different permutations of from 1 to 6. And also same thing we can also do here. So for I in range of 10, and it should be the same as this one because we fixed the seed. So here we see how to generate different different random permutations of a list of items or numbers. So sorry, going back here, we are done with this line of code. What we are going to do in the next videos is going to try to convert the first two rules of packing that we had among those 4 to a Python code and actually generate a feasible solution combining these 2 lines of code together. Okay, see you in the next video.